Okay, let us continue hydrogen. Yesterday I have discussed position of hydrogen in periodic table, properties of hydrogen, its isotope, and the most important part, ortho and para hydrogen. After that we have discussed hydrides. There are three types: ionic hydride, covalent hydrides, and metallic, or you call them interstitial hydrides. Continuing this, let us move on. Properties of water. Properties of water. You all are familiar with water, so you should know its properties. Water, you know it is H2O. Now what are the basic properties of water? Number first, its freezing point is 0 degree centigrade and boiling point is 100 degree centigrade. You know this very well. 100 degree centigrade. Number second, it is polar in nature. Water, it is polar in nature. So a number of inorganic and organic compounds are soluble in it. Because water is polar, so inorganic and organic compound. Inorganic NaCl, it is soluble in water. CuSO4, it is soluble in water. Organic alcohol is soluble in water. Acetic acid, it is soluble in water. Number third, it acts as universal solvent. It acts as universal solvent. Water is behaving as a universal solvent. Number fourth, it exists in liquid state. Water, you know, it exists in liquid state as there is intense intermolecular hydrogen bond in water. There is intense intermolecular hydrogen bonding in water. It behaves as an associated molecule. Number of water molecules are joined with each other. Why? Due to hydrogen bonding. So it behaves as an associated molecule. Number fifth, due to hydrogen bond, it has greater surface tension. Dipole movement and conductivity, because water is containing hydrogen bond. Due to that hydrogen bond, this water molecule has greater dipole movement, greater surface tension, and greater conductivity. Clear? These are the basic properties of water. Now, coming on to its chemical properties. Chemical properties. Chemical properties. Number first, amphoteric nature. amphoteric nature. Amphoteric nature means what? It can behave as both acid and base. Both acid and base. It can behave as both acid as well as base. So its nature is amphoteric. Let us see the reaction. You see HNO3. HNO3 is acid. When it reacts with water, now here water will behave as base. This is converting into what? Nitrate ion plus hydronium ion. Here water was behaving as base. Similarly, if we react water with base, you see ammonia is a base and water is reacted with it. Now here water will behave as acid. What will be the product? Ammonium ion plus OH negative ion. Now you can see. So this water is amphoteric. It can behave as both acid as well as base. Clear? Number second, self-ionization. 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 Water undergoes autoprotolysis to form ions. It is undergoing self-ionization. How? You see the reaction. Water plus water. This is self-ionization. It converts into hydronium ion plus OH negative ion. So this is self-ionization. It is ionizing itself. This is also called autoprotolysis. Clear? This was second. Number third, hydrolysis reaction. It undergoes hydrolysis or it shows. Water shows. Hydrolysis reaction. Hydrolytic reaction with metal and non-metal oxides. Metal and non-metal oxide. It is showing hydrolytic reaction when metal and non-metal oxides are reacted with it. Let us see how. This is the reaction. You are reacting a metal oxide Na2 with water. This is converting into what? 2NaOH. Yes or no? Similarly, you are reacting non-metal oxide with water. It is converting into acid. H2SO3. So it is showing hydrolytic reaction. Clear? This was reaction number 3. Number 4. Action with salts. That is salt. You see this reaction. Salt AlCl3. It is hydrolyzed by water. What is going to happen? It will convert into aluminium hydroxide with what will be liberated? HCl. Clear? Now it is also hydrolyzing salt. We can write over here, it hydrolyzes salt. It hydrolyzes salt. This is its fourth property. Number 5. oxidizing and reducing agent. Oxidizing and reducing agent. Water can behave as both oxidizing as well as reducing agent. You see, water behaves as both. Behaves as both. It is behaving as both. Both means it is behaving as oxidizing agent and reducing agent. Let us see the reaction. This is water plus electron. It is converting into 2OH negative ion plus it is liberate 2OH negative ion plus it will liberate hydrogen plus H2. In this reaction it is behaving as what? Oxidizing agent. It is behaving as oxidizing agent. Okay. Now you can write reaction of water as an oxidizing agent. Suppose sodium metal react with water. It forms what? It forms, you see, 2NaOH plus what will be evolved? Hydrogen is evolved. So this reaction shows that it is behaving as oxidizing agent. Now reducing agent, how it will behave as reducing agent? I am writing over here H2O converts into 4H positive plus O2, oxygen is evolved, plus 4 electron. In this reaction it is behaving as reducing agent. It is behaving as reducing agent. Okay. Now let us see how it is behaving as reducing agent. You can write the reaction here. F2 fluorine reacts with water forming what? HF plus O2 plus O2. Okay, O2. This 4HF 2F2. These reaction shows that it can behave as both oxidizing agent as well as reducing agent. Okay. Number 6 property, hydration. Hydration reaction. Hydration reaction. There, various salts. Various salt takes water as molecule of hydration or water of crystallization. Water of crystallization. There are various salt. There are number of salt in which what has happened? Those salt are taking water molecule and water molecule is attached to it. Let us see the example. CuSO4.5H2O. Now you see, it has taken copper sulfate. It is a colorless salt. When it is mixed with water, becomes blue in color due to this water molecule. Here, 4 water molecule will form coordinate bond and 1 water molecule will be molecule of hydration. It will form hydrogen bond. Clear? There are a number of examples. LiCl.2H2O, etc. You see, it is taking 2 water molecules. So this is hydration reaction. MgCl2, 6H2O. So what salt are taking water molecules. Clear? So whatever I have discussed, this is what chemical property of water. Clear? Now let us move on. A part of our section. Now this is very important what I am teaching you. Ice floats on the surface of water. You have seen it why? Surface of water. Ice floats on the surface of water. Why ice is floating on the surface of water? What is the reason behind it? Why this is happening? You see here, I am writing ice. Clear? The reason for this is ice in solid state has tetrahedral structure. Ice in solid state has tetrahedral structure. You see here, this is ice in solid state. It is having tetrahedral structure. Clear? What is happening in this structure? The oxygen atom forms covalent bond. Oxygen atom forms covalent bond with two hydrogen atom, and at the same time it forms hydrogen bond with hydrogen atom of nearby water molecule. You see here, it is the figure which is showing this. What is happening? This is oxygen atom. It is forming covalent bond with two these are covalent bond with two hydrogen atom. Clear? Now, at the same time, what it has done? It is forming oxygen. It is forming this bond is covalent bond. Same time, it is forming what you can see, hydrogen bond with adjacent water molecule. The intensity, the strength of hydrogen bond, is strong, or a strong hydrogen bond is formed, is strong. There are vacant spaces. In the structure. Now you can see, in this structure there are vacant spaces. When in ice there is intense hydrogen bonding. So what is happening? There are vacant spaces in ice. These are vacant spaces. Okay. It results in a cage structure. Now, due to intense hydrogen bonding, there are spaces. When there are spaces, the density of ice is less. Ice have less density. Now, what was happening after this? When heat is supplied, the bonds are broken, the hydrogen bonds are broken. The tetrahedral structure collapse. The tetrahedral structure start collapsing. Tetrahedral structure starts collapsing. So the molecules come closer to each other. molecules come closer, they will come closer to each other, comes closer to each other, the vacant spaces reduces, the vacant spaces reduces. Now you see, when energy was supplied to ice, what is going to happen? These hydrogen bond are broken. As a result, the tetrahedral structure collapse. It collapses, and these water molecules, they move closer to each other. When they are moving closer to each other, these vacant spaces will die off. They will vanish off. Clear? Then what is going to happen after this? The density of, because they have come closer to each other, the density of water increases. Water increases. So ice floats on its surface because ice has less density. So ice floats on its surface. This was very important. Ice floats on its surface. Okay. Ice has a cage-like structure. When it is having a cage-like structure, this is taking place. B part. Water has maximum density. Water has maximum density at 4 degrees centigrade. Now this is also very important. Water has maximum density at 4 degrees centigrade. Why? Let us discuss, let us see. At 0 degrees centigrade, both solid and liquid state coexist. Solid and liquid state coexist. Coexist. Okay. When temperature is 0 degrees centigrade, then ice and water, both structure are existing. Both state are present. With increase in temperature, when temperature increase, with increase in temperature, the hydrogen bond are broken. The hydrogen bond are broken, just I have told you, and the density of water increases. And the density of water increases. Okay. With increase in temperature, hydrogen bond will split. Water molecule will come closer to each other. Density of water will increase at same time. At same time. With increase in temperature, kinetic energy increases. Kinetic energy increases, which kinetic energy increases. So with increase in kinetic energy, what is going to happen? Which increases the volume. Which increases the volume and density decreases. And density decreases. Clear? This effect is negligible. This effect is negligible. Kinetic and negligible. This effect is negligible till 4 degrees centigrade. Till 4 degrees centigrade, this effect, the effect of kinetic energy is negligible. Understood? With further increase in temperature, when temperature rises more than 4 degree, further increase in temperature, the effect of if temperature is greater than, with further increase in temperature, the effect of density decreases and the effect of kinetic energy increases. Effect of kinetic energy increases beyond 4 degrees centigrade. This is going to happen. The density will decrease and kinetic energy effect will increase. So, at 4 degrees centigrade, water has maximum density. Water has maximum density. This is the answer for it. Understood? You should be clear. There are two effects. One is the effect of density, another is the effect of kinetic energy. Clear? Now, aquatic animals survive in winters. Survives in winters because the top layer of water freezes, but below it water is at 4 degrees centigrade. So aquatic species can breathe, they can survive in winters. Clear? This should be very clear to you what I have taught you. This is all about water. Now, the last portion of this unit, it is heavy water. Heavy water. Heavy water is D2O. It is called deuterium oxide. It was prepared by Urey. It was heavy water. First of all, it was prepared by Urey. Urey was a chemist who prepared heavy water. Its property are similar to water. Its property are similar to water. Okay, but when properties are similar means it has higher boiling point, higher melting point, its mass is more. So only there is a difference of few properties between what? Heavy water and normal water. Clear? Now, it is toxic in nature, it is poisonous. The main thing is this, it is toxic in nature. Why? Because its rate of reaction is very slow. It reacts at a slow rate. Rate of reaction is very slow. Very slow. Clear? It slow down. It slow down the enzymatic reaction. It slow down the enzymatic reaction taking place in plants and animal, because it reacts at a low rate, so it does not support life. It does not support life. This is important. It does not support life. Heavy water or deuterium oxide is toxic in nature. Why it is toxic in nature? Because its rate of reaction, it reacts at a very slower rate It slows down the enzymatic reaction which are taking place in plants and animals. Therefore, when enzymatic reaction are slowed down, then the metabolism of food does not take place. Therefore, it is toxic in nature. It does not support life. This heavy water is not going to support life. Okay. Now, chemical properties. Chemical properties. Chemical properties. Let us see its chemical properties. Number first, electrolysis. Electrolysis. It is electrolyzed just like water. As water is electrolyzed, it is also electrolyzed to D2O, heavy water electrolysis. It is converting into 2D2 deuterium plus O2. Okay, dideuterium. This is called dideuterium. Dideuterium. This is first property. Number second, action with metal. Action with metal. Its property are same to water. Action with metal. You react it with metal. Sodium. It is reacting with heavy water D2O. It is forming what? Sodium deuterite. Sodium deuterite plus D2. This is sodium deuterite. Sodium deuterite. Sodium deuterite is formed. Okay. Next property is action with metal oxides. Number third, action with metal oxides. Action with metal oxides. Now it reacts with metal oxide in same form. Let us see. Calcium oxide, it is reacting with heavy water. It is forming CaOD2. Now you see. Okay. It is forming what? CaOD2. Calcium. Calcium deuteroxide. Clear? Next, action with non-metals. Action with non-metal oxide. Non-metal oxides. Action with non-metal oxides. You can write the reaction yourself. SO2 reacts with heavy water. It will form what? It will form D2SO3. Clear? Understood? So, the reaction are same as that of water. Clear? Now, use. It is used as moderator in nuclear reactors. It is used as moderator in nuclear reactor. It slows down the speed of neutron. It slows down the speed of neutron. Speed of neutron. It slows down the speed of neutron. So this is all about heavy water. This is the portion which you have to study in hydrogen. Now I have taught you each and everything of second part of chemistry. The second part of chemistry finishes here. Now what is your job? What do you have to do? You have to revise each and every chapter. You see this presentation. You download it and see it as many times as you can see until your concepts are very clear in this part of chemistry. Okay, that's all from me, and that's all for second part of chemistry.